On March 7, 2025, China made an announcement that electrified the world. The news spread rapidly, capturing the attention of scientists, policymakers, and everyday people across continents. Headlines flashed on screens, and social media buzzed with speculation and excitement. This wasn't about a distant planet or a far-off galaxy. It was about energy, right here on Earth, and the possibility of transforming how we power our lives. The announcement revealed that China's artificial sun project, the experimental advanced superconducting tokamak, or EAST, had achieved a historic breakthrough in fusion energy, a goal that had eluded scientists for decades. This was no small step. It was a giant leap forward, turning what once seemed like science fiction into tangible reality. The achievement reignited hope for a future powered by clean, limitless energy, free from the pollution and limitations of fossil fuels. Around the globe, as the world grappled with the urgent challenges of climate change and energy insecurity, people everywhere paused to take notice. The significance of this moment was felt in classrooms, boardrooms, and homes alike. For the first time, EAST had demonstrated not just the possibility, but the control and stability needed for sustained fusion, a feat that many experts believed was still decades away. Suddenly, fusion energy was no longer just a theoretical dream. It was happening right now in a laboratory in Hefei, China, with real scientists making real progress. The announcement marked the dawn of a new era, demonstrating what's possible when nations invest in science, share knowledge, and push the boundaries of innovation together. It was a moment of global unity and inspiration. The journey toward practical fusion energy is far from over, but on that day, China's artificial sun shone brightly, a beacon of hope, lighting the way toward a cleaner, more sustainable future for all. When you hear the term artificial sun, you might imagine a new star lighting up our sky. But in reality, it's not a celestial body at all. It's a groundbreaking scientific device, a nuclear fusion reactor, most commonly in the form of a tokamak. These reactors are designed to mimic the very process that powers our sun, but here on Earth under controlled conditions. Imagine a massive donut-shaped chamber engineered with incredible precision. Inside, scientists attempt to recreate the sun's core, a place where temperatures soar to millions of degrees and pressures are unimaginably high. This is where the magic of fusion begins. The main objective is to generate plasma, which is often called the fourth state of matter. To do this, hydrogen gas is heated to such extreme temperatures that the atoms break apart, forming a swirling, luminous soup of charged particles. This plasma is the essential ingredient for fusion. The plasma inside the reactor reaches temperatures even hotter than the sun's core, sometimes over 150 million degrees Celsius. At these temperatures, no known material could contain it, so scientists use powerful magnetic fields to suspend and shape the plasma, keeping it away from the reactor walls. The tokamak's magnetic bottle is a feat of engineering, using intricate arrangements of magnets to hold the plasma in place. This prevents it from cooling down or touching the chamber, which would instantly halt the reaction and damage the equipment. The entire machine is a marvel of modern science, superconducting magnets, advanced heating systems, and ultra-precise controls all working together. It's a symphony of technology pushing the boundaries of what's possible in energy research. By fusing light elements like hydrogen, the reactor releases an enormous amount of energy. This is the same process that fuels every star in the universe, including our own sun, and it's the ultimate goal for clean, nearly limitless power on Earth. The result isn't a star in the traditional sense, but it's the closest humanity has ever come to capturing the power of a star and bottling it safely here on our planet. Fusion is an elegant process. Light atoms merge to form heavier ones, releasing clean energy with no greenhouse gases or long-lived radioactive waste. It's a vision of a future where energy is abundant and sustainable. For the first time in history, we're learning to master the universe's own recipe for creating light and life. Every experiment brings us closer to unlocking the secrets of the stars. The artificial sun represents humanity's boldest and most ambitious attempt to harness the very forces that shape the cosmos, offering hope for a cleaner, brighter future for generations to come. Fusion energy is nothing short of revolutionary. It represents a bold leap forward in our quest for sustainable power, harnessing the same process that fuels the sun and stars. Fusion promises nearly limitless clean power, energy that could meet the needs of our growing world without polluting the planet or depleting precious resources. Its fuel, deuterium from seawater and tritium bred from lithium, is not only abundant but also widely accessible. Oceans hold enough deuterium to power civilization for millions of years, and lithium is found in everyday minerals and even in recycled batteries. The main byproduct of fusion is harmless helium, the same gas used in balloons with no carbon emissions and no long-lived radioactive waste to threaten our environment or future generations. Unlike nuclear fission, fusion cannot melt down. If anything goes wrong, the reaction simply stops, making it inherently safe and reliable with no risk of catastrophic accidents. The energy density is staggering. A single bathtub of water and a laptop battery's worth of lithium could power an average home for decades, eliminating the need for constant fuel supply and reducing our dependence on fossil fuels. Fusion plants would be compact and efficient, requiring far less mining, land and transport than today's sprawling energy systems. This means less environmental disruption and a smaller carbon footprint. In a world desperate to decarbonize and fight climate change, fusion offers a real, practical path to a zero-carbon future, one where clean energy is available to all. It's safe, powerful, and could supply humanity's energy needs for millions of years, ensuring prosperity and security for generations to come. Fusion isn't just another energy source, it's a paradigm shift, a chance to redefine our relationship with energy and the environment. The promise is clear: clean, abundant energy that could transform civilization, lifting billions out of energy poverty and protecting our planet. That's why the world is watching, because fusion could be the breakthrough that changes everything. The March 2025 announcement was built on a stunning achievement just weeks earlier. On January 20th, East sustained a stable plasma loop for 1,066 seconds, nearly 18 minutes, shattering previous records. In fusion research, that's an eternity, proving the technology can endure the extreme conditions needed for real power generation. The key was maintaining H mode, a stable, well-insulated plasma state, crucial for efficient fusion. This record validated East's engineering and control systems, showing the world that long-duration fusion is possible. Plasma is notoriously unstable, but the team's real-time controls kept it contained. This wasn't just a technical milestone, it was proof that fusion's biggest hurdles are being overcome. The achievement laid the foundation for the project's next phase and global confidence in fusion's future. East's record wasn't luck, it was the result of major technological upgrades. The team doubled the reactor's heating power, reaching and sustaining 100 million degrees Celsius. East is the world's first fully superconducting tokamak, using magnets that generate strong, stable fields with zero resistance. A new water-cooled tungsten diverter handled the intense heat and removed impurities, allowing longer runs. These innovations, powerful heating, superconducting magnets, advanced cooling, work together, managed by AI-driven controls. East's success is a showcase of cutting-edge engineering, bringing sustained fusion closer to reality. China's fusion achievements are part of a national strategy backed by major investment and a clear vision. The China Fusion Corporation, launched in 2023, unites research and industry to accelerate fusion's path to market. With $240 million in new investment, China is already planning the next step, the China Fusion Engineering Test Reactor, CFETR. CFETR aims to bridge the gap between experiments and commercial power, testing self-sustaining fuel cycles and net energy gain. This long-term approach shows China's commitment to leading the global fusion race. Fusion is now a national priority, not just a scientific dream. A fusion is a global effort. No nation can do it alone. China is a key partner in ITER, the world's largest fusion project, alongside 34 other countries. Chinese teams contribute advanced components and expertise, gaining access to shared data and technology. East's breakthroughs provide vital insights for ITR and the global fusion community. National projects and international collaborations complement each other, accelerating progress for all. Scientists worldwide share results, learn from failures, and work together to solve fusion's toughest challenges. The pursuit of fusion transcends borders, uniting humanity in the quest for clean energy. Every breakthrough, wherever it happens, brings us all closer to a sustainable future. Despite progress, commercial fusion remains a formidable challenge. No reactor, including East, has yet produced more energy than it consumes. The next milestone is ignition, a self-sustaining reaction where fusion's own heat keeps the plasma burning. ITER aims to achieve this, producing 10 times the input energy. Engineering hurdles remain. Reactors must withstand neutron bombardment, breed their own tritium, and run reliably for years. These challenges will take decades of research and global cooperation to solve. Experts predict commercial fusion power won't arrive before mid-century. China's breakthrough is a milestone, not the finish line on this long journey. Why does China's artificial sun matter to us all? Because it's a beacon of hope in a world facing climate and energy crises. Fusion is an act of optimism, proof that human ingenuity can solve our toughest problems. Clean, safe, limitless energy could transform lives, economies, and the planet itself. East's success shows that with vision and investment, we can make real progress. Fusion offers a way out of fossil fuel dependency and environmental decline. The global quest for fusion unites nations, reminding us that our greatest challenges are shared, and so are our solutions. The light from China's artificial sun is a promise, a future where humanity thrives sustainably. That's a future worth striving for together.